Hello students, welcome to Sharmila's Math. In this video, we are going to see about linear differential equations. What is a linear differential equation? A linear differential equation is of the form dy by dx plus py equal to q. This is a linear differential equation in terms of y. Here dy by dx is having power 1 and y is also having power 1. Such a equation is called linear differential equation. What do you mean by the word linear? Linear means power 1. Y is having power 1 and dy by dx is having power 1. So each term including the derivative, that is dy by dx, is also having power 1. Such kind of equation is called linear differential equation. Here p and q are functions of x, that is in terms of x. First we have to find the integrating factor. In short, we call that as IF. The formula for finding the integrating factor is e power integral p dx. Since p and q are in terms of x, we have to integrate with respect to x. So the formula is e power integral p dx. And come to the solution. This is the last answer. The formula is e power integral p dx into y is equal to integral q e power integral p dx plus c. That is integrating factor if into y equal to integral q into integrating factor and integrating with respect to x, that is dx plus constant of integration c. This is the formula for finding the final solution. Let me explain this using a problem. The given problem is dy by dx plus 3y by x is equal to sin x by x cube. We have to solve this equation and we have to find the solution of this equation. First, you have to check whether this given equation is a linear differential equation. Dy by dx is also having power 1 and y is also having power 1. So we confirm this as a linear differential equation in terms of y. First we have to find out what is our p and what is our q. P means in terms of x and q is also in terms of x. In this term, excluding our y, whatever we have now, the coefficient of y, take that as p. So p is equal to 3 by x. Leaving y, the other term is p. The right side term, what we have now, take that as q. So q is equal to sin x by x cube. After finding p and q, first we have to find the integrating factor. What's the formula for finding the integrating factor? It is e power integral p dx, which is equal to e power integral 3 by x into dx, which is equal to, since 3 is a constant, we can take that outside the integration. So simply we have dx by x. Tell me what's the formula for integrating dx by x? It is log x. So integration of dx by x is log x. So which is equal to e power 3 into, this has the formula log x. When we have a coefficient at the front of log, we can take that to the power of this term. So we can rewrite this as e power log of x to the power of 3 x cube. If we take like this only, we can cancel these two, since e and log are inverse to each other. E into log is equal to 1. Both will cancel among themselves and will get 1. So when we have 3 at the front, we are not able to cancel these two. So first what we are doing is, we are taking this 3 to the power of x. After making that, now we can cancel these two. Finally we have only x cube. Is it clear why we are taking this 3 to the front? So for cancelling e and log. So what we got as the integrating factor is x cube. So we got IF as x cube. Come to the solution. The formula for finding the solution is e power integral p dx. E power integral p dx into y is equal to integral q e power integral p dx dx plus c. So that is we got this term as x cube. So x cube into y equal to integral of, what is our q? Q is sin x by x cube into x power 3 into dx. This is e power integral p dx, right? Into dx plus constant of integration c. We can cancel x cube with x cube. So integral sin x dx plus constant of integration c. Now you tell me, what is the formula for integrating sin x? It is minus cos x. So which is equal to minus cos x plus constant of integration c. That is, this side we have x cube, no? Bring that down to the right side. Therefore, y is equal to minus cos x by taking x cube to the other side. It will come in the denominator, cos x by x cube plus c by x cube. This is my solution. Is it clear? This is problem number 2. We are going to solve the y by dx plus 4x by 1 plus x squared into y is equal to 1 by x squared plus 1 the whole power 3. This is also a linear differential equation. Since these two are having power, this is a linear differential equation in terms of y. So first we have to write what is p and q. P is the coefficient of y. So leaving y, what we have is 4x by 1 plus x squared, and q is 1 by x squared plus 1 the whole power 3. Now the integrating factor has the formula e power integral p dx is equal to e power integral 4x by 1 plus x squared. So e power 4 can be taken out, x by 1 plus x squared dx. For finding this term, let me explain some examples. What is the formula for integrating dx by x? Already we know this. This is log x. Now come to the term given here. Here, after taking 4 outside, we have x by 1 plus x squared into dx. Compare these two powers. Here the power of x, the highest power for x is 2, and the power of x here is 1. Okay, if we have a term like this, better we can go for variable substitution method. Whatever you have in the denominator, no, take that as t. T is equal to 1 plus x squared. Differentiating both sides with respect to the corresponding variables. So dt is equal to, when you differentiate this with respect to x, it is 0 plus, when we differentiate x squared, it is 2x into dx. So dt is equal to 2x dx. In the numerator, we have just x into dx. So bring down this 2 to the other side. So dt by 2 is equal to x dx. Now we are going to replace this as well as this in the integral. So integral for x dx, we can replace it by dt by 2. By 1 plus x squared we took as t. So dt by 2 by t. Here 1 by 2 is constant, so I can take that outside. 1 by 2 integral dt by t. Already we know the formula for dx by x. Dx by x is log x. Similarly, here it is 1 by 2 into log t. Finally, we have to replace t, what we have taken now, 1 plus x squared, that we have to replace it back. So 1 plus x squared. So integral of x dx by 1 plus x squared, we got as 1 by 2 into log of 1 plus x squared. So what we got is e power 4. For this only we got 1 by 2 log of 1 plus x squared. 1 by 2 log of 1 plus x squared. After cancelling 2, we got integrating factor is e power 2 log of 1 plus x squared. Already I told you, don't keep this coefficient here, bring that to the power. So e power log of 1 plus x squared the whole square. Now we can cancel e and log. So final answer for integrating factor is 1 plus x squared the whole square. So integrating factor we got as, after cancelling 2, we got as e power 2 log of 1 plus x squared. So already I told you, take this 2 to the power. So e power log of 1 plus x squared the whole squared. After taking that 2, now we can cancel e and log. So after cancellation, we are getting the integrating factor is 1 plus x squared the whole square. Is it clear? Now come to the solution. The formula is e power integral p dx into y is equal to integral q e power integral p dx plus constant of integration c. So e power integral p dx we got as 1 plus x squared the whole squared into y is equal to q, already we know that it is 1 by x squared plus 1 the whole power 3 into 1 plus x squared the whole squared dx plus c. We can cancel 2, the power 2 squared we have, no, after cancellation this power will become 1. So what we have here is integral of 1 by x squared plus 1 dx plus constant of integration c. We have a formula for integrating dx by x squared plus 1. It is tan inverse of 1 plus constant of, tan inverse of x plus constant of integration c. This is the general formula. Dx by x squared plus a squared is equal to 1 by a tan inverse of x by a plus constant of integration c. This is the general formula. In the place of a we have 1. So 1 by 1 tan inverse of x by 1. That's how we are getting tan inverse of x. So after substitution of that, we are getting it is tan inverse of x plus constant of integration c. Left side what we have is 1 plus x squared the whole square into c. We can take this to the other side. The final solution y is equal to tan inverse of x by 1 plus x squared the whole square plus c by 1 plus x squared the whole square. This is our solution. Is it clear? Thank you.